We talk about the polarization by reflection. OK， 所以就是说，除了那个 polarizing filter 之外，我们还可以用另外一种方式去产生那个极化的光。OK，so a ray of unpolarized light in the air is incident on the glass surface at the so-called Brewster angle. This is called the Brewster angle. The electric field along that ray have been resolved into components perpendicular to the page and the component parallel to the page. Okay, so the reflected light consists only of component perpendicular to the page and is thus polarized in that direction. What does it mean? So here, this one is the incident unpolarized light. Okay, so this is the direction of the wave propagation, and then here we have this yellow orange dot. Okay, and then we also have this green arrow. Okay, so these two also mean the polarization of the E field. Okay, so it is unpolarized, so it has this direction and also have the orange direction going in, going out of the page. Okay, so here if it is in the Brewster angle, okay, later on we'll know this is a Brewster angle. So if the incident line is equal to the Brewster angle, then this reflected ray will be polarized, and this reflected ray will be partially polarized. Okay, 就是部分的极化，因为这边会极化，但是这边没有，就是等于说就是这边本来就是橘色跟绿色的方向是一样的，那有一部分就会跑到反射，那绿色的方向完全不会被反射，那所以全部绿色都会跑过来，橘色的话就是分成两个部分，一部分反射，那这边就是完全的极化，那这边的橘色就会比较弱，所以是叫做 partially polarized， 就是部分的极化。Okay, so and actually it says, as shown in the above figure above, a reflected wave will be fully polarized with its E vectors perpendicular to the plane of incident if it strikes a boundary at the Brewster angle theta B, where theta B is an arctangent of n2 over n1. N2 over n1. And actually we have an interesting characteristic, which is theta B plus theta R will be 90 degrees. This theta B is of course the incident angle, and this will be the refracted angle. Okay, so they add up to be 90 degrees, and of course this is the reflected angle. Okay, so this reflected angle will be the same as the incident angle. So this is theta B, this is theta B. And we still know that this theta B plus theta R will be 90 degrees. Okay, so this is 180. Okay, this one and this one add up to the 90, which means these two will have a 90 degrees between them. Okay, actually it's we can actually prove this property. Okay, so here we have theta B to be arctangent of n2 over n1. Theta B to be arctangent n2 over n1. Okay, so of course we have theta 1 to be theta B. Okay, okay, and then we have theta 2 to be theta R. Okay, and then we have n1 times sine of theta 1 to be n2 times sine of theta 2. So actually we have this is theta 1, which is theta B. So here we have n1 times sine of theta B will be n2 times sine of theta R. Okay, so here we need to calculate sine of theta B. Okay, so here we can draw a right angle triangle. So this is theta B, which means this is n2, this is n1, and this is square root of n1 squared plus n2 squared. So which means sine of theta b will be n2 over square root of n1 square plus n2 square, and then this is n1, this is n2 sine of theta r. Okay, so in such a way we can actually cancel this n2 and n2. Okay, of course in between should be a equal sign. It should be an equal sign. So here we have a sine of theta r should be n1 over n1 square plus n2 square. Okay, which is actually this n1 over this one. Okay, so which means that theta r should be here. Okay, so according to this one, theta b plus theta r should be perfectly 90 degrees. Should be perfectly 90 degrees. Okay, so finally we have some additional examples. So this one, it says unpolarized light is sent to system of 3 polarizing filter. The angle theta 1, theta 2, theta 3 of the polarizing direction are measured counterclockwise from the positive direction of the y-axis. So the angle theta 1, theta 3 are fixed. Okay, 这两个是固定的。But angle theta 2 can be varied. Theta 2是可以动的。Okay, so the intensity of the light imagined from the sheet 3 as function of theta 2. Okay, the scale of the intensity axis is not indicated. Okay, 就是它没有告诉你说这个中轴是什么啊，它只是告诉你它有这样的形状而已。然后它也是说这几个角度也是乱画的，就是你不要看着那几个角度是什么就以为是什么。Okay, so it asks you what percentage of the light initial intensity is transmitted by the system when theta 2 equals 30 degrees. So 30 degrees is somewhere like here. Okay, so this is 45, this is 30. Okay, but it doesn't tell you what I0 is. Okay, so it asks you what is the percentage of the initial intensity. Okay, this is just the excess of I. It doesn't tell you what is I0. I0 can be somewhere higher, much higher than this peak. Okay, because the filter will actually block most of the wave. Okay, so here actually we can have some observation. So here we can observe that when theta 2 equals 0 degree, 90 degree, and 180 degree. Okay, so in these cases, I is perfectly 0. Okay, so this is the very important point here. So here we can observe I equals 0 at theta 2 equals 0 degree, 90 degree, and 180 degree. So actually 0 degree and 180 is actually the same. Okay, so if you consider, this is 0 degree and 180 degree, just rotated by 180 degree. So the polarizing filter doesn't make any change. So you just consider, here we have 0 degree and 90 degree. So here, if I equals 0 at this angle and this angle, it means that theta 1 equals 0 degree and then theta 3 equals 90 degree. Or of course it can be reversed. It can also be theta 1 equals 90 degree theta 2 equals 0 degree is also okay, but yeah, they will give you the same result. So without loss of generality, we can just assume theta 1 equals 0 degree and theta 3 equals 90 degree. It's also okay. It's also okay. Yeah. So why it will be 0 degree 90 degree? Because if theta 1, so at least one of it is 0 degree. So when theta 2 is also 0 degree, so they point to the same direction. But theta 2 and theta 3 will have a 90 degree between them. So that the cosine of 90 degree will give you a 0. And for the 90 degree, when theta equals 90 degree, then this 90 degree, this theta 2 and theta 1 will have a 90 degree in between. So yeah, so when the lights go through theta 2, okay, then all the way will be blocked. Okay, so which means if there are some zero at 0 degree 90 degree, which means theta 1, theta 3 should be at least one to be 0 degree, one to be 90 degree. Okay, so here the remaining stuff is to find what is I. This is I0, I1, I2, I3. Okay, what is I3 when theta 2 is 30 degree? Okay. Okay, so IF over I0 will be, okay, so at the beginning it is unpolarized, so for the first one will be 1/2, and then times, okay, the first one is, this one is 0 degree, this one is 30 degree, this one is 90 degree. Okay, so between the first one and the second one, we have a 30 degree in between, so we have a cosine of 30 degree square. And then between the second and third, we have a 60 degree in between, so we have cosine square of 60 degree. Okay, so in such a way, we have 9.4%, actually the same answer as the previous sample problem. Yeah, but actually, we need to determine the angle of theta 1 and theta 3 first according to this figure. Okay, and then after or choosing theta 1 and theta 3, or after determining theta 1 and theta 3, we will be able to calculate the intensity ratio of the final way and the original way. Okay, so next we have another additional example. So here it says a certain helium-neon laser, 就是氦氖镭射 okay, emits red light in a narrow band of wavelengths centered at this wavelength, and then with a wavelength width of 0.0100 nanometer. What is the corresponding frequency width of the emission? 那这个的话算起来很简单，但是你们可能比较难想象它是什么意思。因为就是说，它的意思是说，有一个氦氖镭射，它的波长的中间在这个632.8 nanometer。什么叫做波长的中间？那如果你以一个轴是波长的话，我们一般想象，比如说我有一个波长是这个的话，它就是一个 cosine kx 减 omega t， 就是一个很完美的，就比如说 E等于这个 EM cosine kx 嘛，那这个 omega 是一个数 ，OK， 那如果这样的话，它会对应一个波长嘛？这个波长是k 等于 2 派除以 lambda 嘛，所以就是 lambda 等于2派除以 k 那这个 lambda 是一个数，就是一个数嘛。那如果在这个轴上要表示的话，它就是只有一个箭头，就是只有在 lambda 等于某一个 lambda 0的时候，它才有，其他的都没有。但是现实的话就不会那么美好的，现实的话不会那么美好的。 现实的话会怎么样呢？现实的话，它会集中在某一个你真的想要产生一个单屏的，它也没有那么样。那正常的话，如果你乱来的话，它就是可能就是一个很宽的一个normal distribution。你要弄成一个雷射的话，它可能还是窄一些，但是在附近的地方还是有一些别的波长，那也就是会对应到一些别的频率了，因为 C 等于 F lambda 嘛，或者是2 pi omega lambda 除以2 pi 嘛，那就是lambda 会变，那 F 也自然会变 ，F 会变，那 omega 也自然会变嘛，所以也就是说它就是有一些不同的lambda 会掺杂在这里面你没有办法去完全排除那个 lambda 不是你想要的那个 lambda， 有一些很接近的，你就没办法排除了，简单说是这样。那 center 的话就是说你可以当成是一个平均，它平均就是这个这个就是我们的 lambda 0这个就是我们的 lambda 0，就是一个 center， 你可以看作是一个平均或者是什么中位数，通常那个平均就可以了。如果这个数量足够多，或者是它像一个 normal distribution 的话，那平均你可以当作是一个平均值。然后这里就会说那个 wave width of 0.01那个 wavelength width 是什么？它就是指这里我们比如说这里这个高度我们取一半那这里的宽度我们就叫做wavelength width wavelength width。Okay, so it asks you what is the corresponding frequency width for the emission 那所以刚才就说嘛 ，C 等于 F lambda， 那这个 C 是固定的，那所以比如说我在这里取一点 lambda 0，我带进去，我就会有一个 F 0。我如果这里lambda 0取一个 lambda 比 lambda 0小一些的话，我会得到一个 F 会比 F 0会来得大，就是比如说我带C 等于F 0 lambda 0 ，OK， 然后比如说我这里取一个叫做 lambda 1的，这个 lambda 1会比那个 lambda 0来的小如果是 lambda 1比 lambda 0小的话，那 C 就会等于一个 F 1 lambda 1，那这个 F 1因为 lambda 1比 lambda 0小嘛，那所以 F 1就会比 F 0来的大 ，OK， 因为它们要乘回去，一个 C 是固定的。那或者是我又取一个 lambda 2在右手边的lambda 2如果是比 lambda 0大的话 ，C 等于 F 2 lambda 2，那 F 2的话就会比 F 0来的小，因为这比 lambda 0长了的话，频率就会变小。那所以的话，你这样对应过去之后，你也会有一张这个是频率的轴 ，OK， 也是会有一个像一个 normal distribution 的东西，或者是一个中间建起来的一个东西。那这个就是我们的 F 0，那它最后就是问你这个 delta F 是什么？那这边是 delta lambda，delta F。Okay, so here we can actually calculate so actually we have a F equals C over lambda. Okay, so actually this one, okay, we just try to move lambda to the left side, so we have F over C over lambda. And then we can take the differential on both sides, so we have a dF equals d C over lambda. Of course, C is a constant. So here we got F is a variable, lambda is a variable. So here, if you consider lambda to be a variable, taking the differential will be like C over lambda square, and then the minus sign, and then here we have a d lambda. Or if you don't get used to this expression, if I try to write it like this, df d lambda, df d lambda, okay, will be equal to d lambda c over lambda, okay, and then c is a constant, so here we have c times d lambda, and then 1 over lambda, okay, so this is lambda to the negative 1 power, so the derivative will be c times negative 1 over lambda squared, okay, so this is actually this one, okay, and then you try to move this d lambda to the right side, which is actually this one. Okay, so here we can try to plug in all the things into there. So we have df equals negative c over lambda squared d lambda, and then we have a 3 times 10 to the 8th power, which is the speed of light, over lambda square. Lambda is this one, so 632.8 times 10 to negative 9th square, and then times d lambda. D lambda is this wavelength width. Okay, will be 0.01, and then times 10 to negative 9th. Okay, so it corresponds to 7.49 gigahertz. 7.49 gigahertz. Okay, so this 7.49 gigahertz frequency variance seems like very large, but actually you can try, if you have interest, you can try to really calculate what is f0 equals c over lambda, c over lambda. So this is actually 3 times 10 to the 8th power, and then over this 632.8 times 10 to the negative 9th power. Okay, so yeah, this one will be like will be around 1 over 200, and then this one will be times 10 to the 17th power. Okay, so this is somehow like 5 times 10 to the 14th power. Okay, if I yeah, should be right. Okay, so we pick out 10 to the 3rd power divided by this one will be 5, and then this is 10 to the 14th power. Okay, 10 to the 14th power, this is 10 to the 9th power. Okay, so this is not, so comparing to this frequency, this 7.49 gigahertz is not that large. It's not that large. OK， 但我们是用的微积分去算这个 delta f 或者 df 是什么嘛？那如果你有兴趣的话，你也可以试着考虑说，你尝试去算一下 lambda 1跟 lambda 2啊，那 lambda 1就是那个 lambda 减去2分之 delta lambda， 然后 lambda 2就是等于lambda 加上 delta lambda 除以2。然后你用 lambda 1、lambda 2去算这个 f1、f2， 然后去相减，看是不是跟这个差不多，应该会差不多，因为这个是微分嘛，微分其实是跟那个是一个 approximating 的关系，是一个 approximating 的关系，它不一定完全相等，但是应该是差不多才对。OK。